Hello class, this is a visual proof of the difference of two squares. See, it's one thing just to know how to do the factorization, but it's nice to be able to see where it actually comes from. So here we have two squares. I have a big square here with side A. So I'm going to label this side A. And if I found the area of the big square, don't worry about that one, just the big square, we get a squared, right? And then this little square here is b. That area would be b squared. So now if I were to take that block away, right, I'm going to prove to you that this area, so the proof is going to be, once again, that if we have two squares, a squared minus b squared is the same as a plus b, a minus b, like that. Okay, so how we're going to do this is this corner to that corner, we're going to draw a line there. There we go. Make it as neat as we can. Now, if you can imagine, we're actually going to cut this shape out and we're going to flip it over. But before we do this, this length, I want you to think about what the length of this is. So take a look. If this is A, this must also be A. So if that is A, this one must also be the length of A. And if this is B, this is also B, because remember this is a square. So if that's A, and this is B, this remaining must be A minus B. Okay? A minus B. And this one here must also be A minus B. Okay, so that there is, that's A minus B. Okay, so now I'm going to redraw this, but see this line here? I'm going to flip this entire shape. So I'm going to take this shape here, the one I'm highlighting, and I'm going to flip it over. Watch what it's going to look like, okay? Just so that we get everything a little bit accurate here. It's going to be 1, a bit over 1. It's going to be about 3 and a bit centimeters. I made this 4 centimeters. And here's that line that we cut. So can you see where this is? So there it is there. So I'm going to finish off this square here. So there's that area again. Now if you take a look, if that is A minus B, just gotta erase a few things here. If that was A minus B, this is still A minus B. that was A minus B. Okay. Now let's take a look here. If you take a look, this side was B. There it was. So that was still B. Okay. And if you take a look, if that was B here, that must also be B up in that little segment here. Just gonna draw it there. Okay. And take a look, if that was also A, wasn't it? That's A. That one there is also A. So that is A. Now take a look at the area. I'm going to take a look at the area of this shape here. Wasn't this A squared? Take a look. Whoops. A squared, which is the entire thing. A squared. And if we subtract B squared, right, so it's still the same area. So now think about that. Look, what is the area of the entire shape here? Well, for the area of a rectangle, okay, the area of this rectangle is going to be this side times this side. Well, this side is A, so we'll go area. Well, this length, we'll call this the length. That's the length. And this is the breadth times breadth. BR for breadth. But the length is length AB. A plus B. So the length is A plus B. And the breadth is A minus B. So take a look at that. The area of this shape, which was, whoops, do it in lowercase, which was A squared minus this little square in the corner, is the same as if we made it into a rectangle of A plus B, A minus B. So these two areas are the same. Hence why we just proved that A squared minus B squared is equal to A plus B in a group times A minus B.